Okay, guys, let's go. Let's start with a financial tool that is crucial for a lot of things. Okay, even personally, this topic is really important for you guys. So the name of this one here is called amortizations. Okay, or also known annuities. So how this works? Examples of this one here are mortgages, for example. We have any other type of loans. Got it? So the basic idea of this one here, I will not do the math here. I will just give you the basic idea. You receive a loan today, okay, for your car, for example, and then you're gonna repay this one here, let's say monthly. Okay, so you're gonna have a series of cash flows for n periods. And that's it. So you receive, I don't know, let's say you receive $100,000. It's a loan, and then you're gonna pay monthly payments for, I don't know, 6 years or 5 years. Exactly. Do you understand? So the logic of this one here, the known here, we normally know the cash, the original cash flow, the amount of money you're gonna borrow. But what you want to know is the PMT. Now, the way you compute the PMT and the CO, the relationship, is very simple. It's simply the present value of each of these cash flows. Okay, so this is going to be 1 plus I. The second one is going to be 1 plus I discounted square plus n payments discounted all to present to time zero. Okay? And that's it. Now, if you do some mathematics with this one here, guys, you're going to arrive to the following conclusion. So if you do some math here, the payments are going to be basically 1 plus I to the n times I over 1 plus I to the n minus 1, all this multiplied by the present value of C0. So this is going to be your formula. Okay? In order to compute my payment, I need to know the interest rate, I need to know how many periods, and I need to know my principal value. So everything is given, is data, so it should be very straightforward to do this. Now, I will show you in Excel how this works. Are you with me, guys?
Yes.
Yes.
Okay. So let's do this. Do you have Excel, right? Can you open Excel? Let's do this by Excel, and then we're gonna replicate this in MATLAB, and we're gonna do more things with MATLAB. So let's copy this part here, up to here, up to here, up to here, up to here. So what we have is we have a loan for $10,000. My annual interest rate is gonna be 5%. I will pay monthly, so I have 12 payments in a year. And then what we need to do, first of all, is compute what is my equivalent interest rate. Okay. I will give you this also. If you have, for example, guys, if you have an interest rate for 1 year, and this is 7%, I think it's 7% here, 5%. The interest rate is 5% per year. Okay, so the way you compute the interest rate for 1 month is equal to 1 plus 0.05 to the power of something minus 1. Okay, just to remember how the power works is the dates of this one here go to the numerator, and the period of this one here goes in the denominator. Okay, so I'm looking for 1 month, so I put 1 month here. And this 5% corresponds to 1 year. I cannot write here 1 year, right? Because the units are not equal. But I can write 1 year equals 12 months. And that's it. So if you compute this number here, so it's going to be 1.05, 1.05 to the power 1 over 12. We get minus 1. We get 0.004074. Or if you want, in percentage terms, if you multiply this times 100, oh, sorry. So you're going to obtain 0.4074%. That is just it. Now, if you want to compute, for example, what is my interest rate for 3 months? We apply the same technique. This is the one that we're going to use for this example, for our examples, this one here. This one here. But just to give you an example how this works, this is one of the most generic formulas. It's 105 to the power of something minus 1. What goes up in this example?
3.
3, exactly. And down?
Same 12.
12. That's it. Okay, of course, 3 months, 12 months. And then you simply use a calculator and get it. Okay, so let's go. And can you do this in 2 minutes? Just this one here, this is my interest rate per month. So it's 1 plus B2. 1 plus is going to be 1.05 to the power 1 over 12 minus 1. What I did a couple of minutes ago. And then my factor is what I told you. So this is the formula that I mentioned to you here. This formula here. 1 plus I to the n times I, 1 plus I. Let me be sure that this parenthesis is indeed is a parenthesis of all this block. Simply the formula goes 1 plus I to the power n times I divided by 1 plus I to the power n minus 1. And this is what is known as a factor. And then from here, it's very simple. You multiply this factor times the principal, and then you obtain your monthly payments. Okay, just if you can just compute this part here very quickly.
Professor,
Yes.
when you have a chance, can you look at the second recording of the last class? It's private, I think. I think we
Don't, I
can't.
changed this in the morning, very early in the morning. Can you
Oh,
verify? Yeah,
okay.
someone was mentioning that also. So I put it public in very early in the morning. Can
Okay.
you take a look right now if
Yeah,
you have
I'm
time?
looking right now.
Yep.
Yes, I can see it.
Perfect. Yep. Okay, guys, one more minute to replicate this part here. I want you to be able to replicate this one here. This one here, the formulas, let me put this bigger so you can take a look to the formula. Just put the numbers in the same positions I have so you can see the formulas. These B4, B3 are going to be exactly the same.
Professor,
Yes,
can you explain again what the factor is?
yes, the factor is this one here, is this part here.
I think we're looking at the Excel.
Oh, okay, so let me go back. Why is it's not doing this stuff to me? Give me 1 second.
Okay.
Need to reshare. Okay, now?
Yeah.
Okay, so the factor is this part here. This part here.
Sorry,
1
I
plus
can't see.
I, you cannot?
Oh, yeah. Now I can.
Yeah, it's this part here. This is the factor. All this part.
Okay.
Okay.
Okay. Thank
Go
you.
back to Excel or prefer to have the formula? Because what I want from you guys is that, in mathematics, economics, and finance, we normally have formulas. So what I
Mhm.
want from you is to apply the formula in the program and create your own programs. Okay.
Okay.
Okay, let me go to Excel. Let me move this file like that. Ready, guys? Have you been able to find this 855.57?
Yes.
Okay, everyone?
Yes.
Yeah.
Excellent. Okay, so what comes next, guys? So what is the idea here? You have a loan for 12 months. You pay monthly. Your interest rate, annual interest rate is 5%. That is equivalent to 0.04 monthly. Your factor is this number, simply your factor multiplied by the principal value equals your payment. Okay. So when you go to a bank or any lender, they're going to give you, this is what is called the the schedule of payments. What is the schedule of payment consistent of? Okay, it has a principal. This is the amount of money you owe to the bank or to the lender. Capital means the amortization you are doing. Amortization is simply how much money you are paying from this principal. The interest is always computed on the principal that you have at the specific month. And the payment is this one here. So how this works, I start with $10,000. I always copy my payment. It's always going to be $855. Got it? And then my interest, how do I compute my interest? Take a look. It's going to be my available principal, $10,000, multiplied by my monthly rate. It's always like that. The next one is going to be, how much money do I have? I have $1,000. I have paid 814. By the way, 814 is computed simply as the difference between the payment minus the interest. Okay, so this is the way it works. Is the payment minus the interest, give me my capital. Make sense to you? And then this one here, my principal, is going to be simply equal to 10,000 minus what I have paid in a period. I have my new principal. And then you continue the other step. My new interest is going to be how much money I owe to a bank times the interest rate. My capital payment is the payment minus this one, gives me this one, etc. And the way to verify, guys, that you are in the correct way, you have done this correctly, is that the last period, the principal must be equal to the capital, because this implies that at the last period you have enough money, or you're paying exactly enough to cover this debt, and then this debt disappears. One thing that is very interesting, guys, is that the capital at the very beginning, or the interest at the very beginning, starts high and decreases in time. And the capital is the opposite. The capital starts low and then increases in time. Correct? So that's why it's so crucial, guys, when you have a loan, to try to pay as much as you can from your principal. Okay, I will show you a graph later in MATLAB. Make sense to everyone?
Yes.
Okay. So let's try to do this in MATLAB using first formulas, and we're going to program this one here. So this is going to be one of our programs, okay? What I want to show you guys now is, let's go to MATLAB. Do you see MATLAB?
Yeah.
Yes.
Okay, so what we are going to be doing here, let's create a new, do you see this cross here, new? Do you see that, guys?
Yeah.
New.
Mhm.
Okay, just create new script. And we are going to create our first very simple program, okay? We're going to create a very simple program here. So the way MATLAB programs work is you need to define first this as a function. And my function is going to be, let's call it my amortization. This is going to be the name of my file. And then you can go as save as, and you save it wherever you're going to have your programs and your material for this class. I have it in summer 2021 programming MATLAB file. So my amortization is going to be saved here. Now, the first thing that you normally have in a MATLAB program is something that you describe your model. You describe what you're doing here. For example, this program computes, period amortizations for a given loan and period, something like that. This is the description of your program. So I suggest you to do this. First describe, because you are not the only one that are going to use your program, but someone is going to be using. You can also enter here, for example, this programs input are. Then you can start describing, right? We're going to fill more. But this part here, guys, is not readable by MATLAB. When you have this percentage term, so MATLAB is going to completely ignore the row. Let's try to replicate what we have done here. The data that we have is PV and the annual interest rate. That's all what we need. Do you agree? So let's do this. So let's put data. I need my PV, my loan principal, and let's write this equal to $10,000. And then I have my interest annual that we said is 5%. Make sense, guys? So we have a lot of things that are missing in our programming. We are not going to do our own old program. We are going to use others program, already built-in programs, because we need to have for loops, while loops, and we need to do if conditions, etc. We have not yet there, but let's try to do something that is using MATLAB programs. It's more or less like using Python programs already built in, etc. Okay, so what I can do is I can compute my monthly interest rate. So I can do interest monthly. If I want to use my formula, it's going to be 1 plus my annual interest rate. Oh, sorry, I need periods. So let's say 12. And I can make a comment here. Sorry, you cannot do 0.05. It's 0.05. It's not percent. Here I put monthly payments for a year. I compute my monthly interest rate. It's going to be 1 plus 1 annual to the power 1 divided by periods. Minus 1. You agree with me? So this is the formula, this formula here. This one.
Yeah.
Okay. Then if we want, just for fun, let's create what is my monthly interest rate. Sorry, not my factor. Okay, so my factor should equal to what? It's going to be 1 plus I, so let me do two parentheses. It's going to be 1 plus I monthly, this one, to the power periods. This one times my monthly interest rate. And then all this is going to be divided by uh, 1 plus I to the n minus 1. I think this should work. Okay, you tell me, guys, when you're with me. Oh my.
Yeah.
Yeah, I need to go back and I need to always forget to record it. Okay, so I will repeat what I am doing here. We are creating a function. A function starts with a word function. This is the name of your function. Then when you save, you're going to save with this name, and you're going to save it wherever you have your files. Then what we're doing is the first part of all programs, MATLAB file programs, always have the description first. It's not always. This is not a must. But I suggest you to do a brief description of what your program is doing, what the program needs to be run, etc. So we're going to fulfill this. We're going to fill this later. Okay. I'm just entering the data here. I have my PV, my loan, $10,000. My annual interest rate, 5%, 0.05. The number of periods, 12. Monthly payments for a year. Then I have my monthly interest rate is 1 plus I, the annual, to the power 1 divided by number of periods, minus 1. And then what I do is computing my factor. Remember, my factor is this one here. Is 1 plus I times I, 1 plus I to the n times I divided by 1 plus I to the n minus 1. This is what is known as my factor. Once we have the factor, we can compute the payment simply multiplying this by C0. Okay, so that's what we're going to be doing now. So up to now, apparently my formula is correct. Yeah, I don't know. So let's try. So one of the things that is beautiful about this part here, guys, is that we can do debugging. Oh, there is something that is wrong here. So let me save. I will write a D. You know, a D is for me is simply D. And D is not part of the program. However, when you debug, guys, why is not giving me red here? Oh, perhaps it's the name. Sorry, I cannot use factor here. I will just use F, okay? Because factor is a reserved word for MATLAB. Okay, I will call this F. And let's try to run. So when you want to debug, you simply you see appear something here. Oh, resolve error. So I have an error. What is my error? You see error found, click to go to the next message. Okay, what is my error? Oh, here we have an error in my, should be, I think it's this one here.
Professor, I see MATLAB frozen.
Oh, MATLAB frozen?
Yeah, me too.
Okay, so let me move this again. Now, do you see my MATLAB?
Yeah. I think you forgot the multiplication sign.
Where's
On
that?
I'm on.
Ah, no. Oh, it
No,
is
on
here.
top.
Power of
On
one
line
over period.
16,
Oh, yeah.
power.
It is 1 plus, here we go. Here we go.
Yeah.
You are completely right. No, it's to the power. Right. I think I have one more parenthesis, one not needed parenthesis. Let's take a look. 1 plus I to number of periods, this close parenthesis, times 1, this close, this parenthesis. So this is okay, right? Should work now. Now, when this works, this one becomes red. You see, you are seeing my MATLAB?
Yes.
Okay, so everyone's with me? Guys, you're with me? Okay, so now we have done that. So what is D? Is you can write any letter, guys. I always use D. I don't know why. But what is interesting is I want the program to run everything and stop here. Got it? So how do we run? We simply, you are in the editor. You need to go to the editor and just click run. And that's it. So you can take a look. If you move the mouse on the variable names, you see PV is a double 1,000 or 10,000. My interest annual is 0.05. I can compute my monthly interest rate. You see 0.00041. This is correct. And let's take a look to my factor F 0.0856. Let's take a look to Excel. 0.566. Perfect. Make sense? So we are in a right way, guys. Agree?
Yes.
Okay, so up to now we have done a good job. So now how do I compute my payment? I will call it PMT. Hopefully it's not a reserved name. And my PMT is going to be equal to what? PB times factor. Do you agree?
Yes.
Yes.
And then basically we can save again and run again. And here I have my payment, 855,560. That is the same that we got in here. Okay. In order, guys, we're going to continue this program later, perhaps tomorrow once we finish all the conditionals. But what we can do at this point is to use something that we always do. Is you don't need to be creating, you are going to create a program just for fun, okay? Using all this data. But also, guys, what you can do is you can use a program that has been already built by MATLAB, okay? So let's comment this one here using MATLAB built-in program. Okay. This is to be continued. And for now, we're going to be using the MATLAB built-in program. The MATLAB built-in program, guys, basically creates everything that we can that we need. So there is a program. We just write the principal. This is the order of the program, okay? Interest. These are names that I will use. Interest, balance, and payment. And the MATLAB command is called amortize. Amortize. What is the input of amortize? My monthly rate. What is my monthly rate? This one. My number of periods. And of course, my loan, my PB. Okay. I will explain to you in a minute what is this, how this works. Can you copy up to here so we are all in line? And let me do something. Are you with me? Guys, you ready?
Yeah.
Okay,
Yes.
so a little, remember guys, when you don't know something, just do the help. And I want you to understand how the amortize works. So let's take a look. Help amortize. And what is the definition? The first definition. Here. This is the order in which the data is returned. The principal value, the interest, the balance, and the payment. Okay, and this is what you need to enter. You need to enter a rate, the number of periods, and the present value. So that's what we have done. The interest rate, the period interest rate, you cannot enter 12, the annual rate, okay? I'm not entering the 5%. I need to transform first the rate into the period, of payment periods. And then I need to enter my loan, the present value. Now, the order in which you enter this one, the names can be different. You see, in the main program, they call it print P. In P, val, and P, I call it principal, interest, balance, and payment. The names can be different, but the order of the variables must be exactly the same like this one here. So I cannot, if I write balance, for example, at the very beginning, it's going to be, MATLAB doesn't have an idea that you have misplaced these names. Make sense to you?
Yes.
Okay.
Yeah.
Okay. So with this done, I'm done. So I can simply run this program and let's see what do we have. So I will copy this one here. Sorry, I will save this one here. Let's run. I don't need this. Yeah, let's run this one. Let's run. And take a look to what you have. You have principal. Take a look to the dimension. It's a raw vector. 1 times 12. Take a look to the numbers, guys. 800, 814, 818, etc. Okay? So this goes in here. Take a look. 814, 818, 821, etc. So the principal is this part here. Oh, wait a second. Yes, the principal for these guys is what I call, I should not call this principal. This is my balance, is my principal. And this is so let's take a look. This one here indeed is not my balance. This is well, let's call it balance. It's okay. It's okay. But we need to understand that this one here, guys, is the amount of money I'm paying from my loan. This is the interest I'm paying from the loan, and this is what is left to be paid. Okay. So if I name this according to this one here is going to be balance. This one here is going to be principal payment, interest, and payment. Got it? So this is the naming convention, following the naming conventions of MATLAB. Balance is the amount of money I still owe to a bank. Principal is the principal payment of my balance. Interest is the interest payment. Okay? So just to follow up the same notation as MATLAB. Okay? So for you, take a look to everyone got these values. Principal is 1 times 12. Interest is 1 times 12. Take a look, 40, 37. 40, 37. Perfect. The balance sheet and the payment. Okay? Now, what I want from you guys, you see, you have all the data here. What I want from you, so are you with me here?
Yes.
What I want is to create the schedule. The schedule is this one here. So you have all the data. Be careful that payment is only one number. So you need to do something. And I want you to put the principal, the interest balance, etc., to create exactly this report. Okay? So let's say 3 minutes. So create this exact report using MATLAB. 3 minutes. I will stop. Please remind me to continue recording later. 3 minutes, guys. We'll bring some water. Yes, I'm back. If you have questions. Okay. So let's try to do this. I will continue recording. So what we're trying to do is we got this data, we got all the results, we have everything. So what we simply want is to create this table here. Okay, so that's the objective. What we need to understand, first of all, guys, is that the dimensions need to match. So let's go into here. I know that the principal is a 1 times 12, interest is a 1 times 12, balance is a 1 times 12. So I can call a schedule table, and I want this to be, okay, so the balance first, right? Just to be equal to the Excel one. Transpose. So what I'm doing by transposing, guys, is my 1 times 12 is going to become 12 times 1. So instead of a row, it's going to become now a column. Then I need to have my principal. Then I need, principal also transposed. And then I have my, what is my interest? Transposed. Aha, I have a problem here. Payment. Payment is a single number, guys, and I want this to be replicated 12 times. So what do I use to create a payment that is a 12 times 1 that repeats the same number? So will move this a little down. I will create payment table, okay? How do I do this? What do I do? So what I want is this part here. This one here. It's the same number repeating 12 times. What technique do I use, or what command do I use? Guys, someone. Someone?
Can we use the rep mat?
The red mat reshape.
Mhm.
Remember, we have a reshape, guys. We have used this reshape before. So what I want is what? I want to reshape this number here. How many rows? How many rows, guys?
12.
12 and one column. Do I agree? Now, I don't like to have hard numbers here because if I change the model, I want to imagine this is a different number here. So how do I make this 12? To MATLAB to read this 12? Remember, do we use what? Yeah, we can use periods, right? Correct. Or we can use, let's use only, you're right, huh? But we can use size command. We can say size principal. Oh, what happened? 1 second, I know what happened with my mouse. Oh, not responding. Give me 1 second. Here you go. Principal 2. Why I'm using 2 here, guys? What is this notation? Size principal 2. What is this one? 2. This 2 means
Is the number of columns.
number of columns. I'm using 2 because remember, principal is 1 times 12. So that's what I'm using 2. So then what you're going to be creating, this is going to be now in the right dimensions, correct? It's going to be a 12 times 1. So you simply put it here. And that's it. So let's save it and let's run. Oh, reshape payment size principal 2. Okay, so what is the problem here? So if we have a problem, I can stop it here. So let's rerun again. Then payment is a 1 by 1. Size of principal, comma 2 is going to be 12. If I want to test this stuff, I copy and then I put it here, 12. Reshape. Yeah, this is okay. Should work. So what is the problem here? So let's take a look here. We'll put this here. Oh, number of elements must not change. Use. Oh, it's not reshape. We are using repmat. Sorry for that. It's repmat, the command that we're using, not reshape. So now let's take a look to this. Yes, it works. So it is repmat, guys. I know why I was using reshape. It's a different command. Okay, so now it should work. So let's take a look. Let's run. Take a look to my schedule, guys. My principal, yeah, you know what? We cannot read in this way. So why don't we do something here that is called format bank? Remember we did that last time? Just to have it more readable. Here you go. 9,185, etc., etc., etc. It goes to 0. The last payment is 0. Make sense to everyone?
Yes.
Oh, yes. But take a look to this table, guys. This table here is different than ours. You see the first value is not the $10,000. I want the $10,000 to be here and this to move down. Because the balance always loses one period. So what I want, the 10,000, take a look to this one here. 10,000 must be my first number and should be on top of all these ones here. Okay, you do it. We need to do something more with the balance. Let's create balance auxiliary, okay? Balance aux. Okay, you do it. So what I want is that the last 0 disappearing from my balance. I don't care about the last 0. And I want to put $10,000 here. So create your balance auxiliary in such a way that is automatic later. So if we change the data, we change anything, the MATLAB is not going to put the correct number. So basically, I'm telling you use the names. Okay, 1 minute. Okay, so guys, that's why we have been learning how to manipulate matrices, okay? How to create matrices from existing matrices, etc. So that's why it's crucial for you to understand this type of things that we have been doing up to now. Okay, you tell me. I want to create a matrix. So balance aux is going to be equal to what? What is going to be the first element? Guys, the first element. PV? Agree with me or not? Guys, you agree with me?
Sorry, yeah.
Okay, so PV is my 10,000. So I will put next to it because the balance, I want the balance from what to what. I want take the data from the balance
From 1 to -1. To the
from
end.
yeah, from 1 to the end, but this is
-1.
-1, exactly. And this is going to be flexible, right? If I change PV, if I change the balance, more data, less data, etc., it's going to be
Yeah.
1 to n -1, should basically not consider the last zero. Okay? And then we replace this balance here with this balance here. Should work. Let's take a look. Here we go. It's exactly the same as the one that we have. And this is normally the one that the banks give you, the banks provide you when you get a loan. Guys, it's clear?
Yeah.
Okay. So we can add something more to our program. Let's add some plots. And what I want to use, I want to plot, for example, let's plot the original data. Let's plot the balance. The balance. A simple balance. And I want this to be on black color. Let's do a hold on. Remember, why do we use hold on? Do you remember, guys, when do we use hold on?
To keep the plot.
Yes, so it's going to be the same plot. It's going to be making more graphs in the same plot. So now I want to plot. I want to do count sum. It's a cumulative sum, guys. And I want to cumulative sum of my principal. Oh, what's going on here? My principal. Perhaps this one can be, I don't know. black lines like that. And then I can do a count of my interest. And let's call these dots in red. And of course, let's put some labels, X label. Let's do Y label. Let's do perhaps grid on, not grid on. Let's have title. What do we want to write? And this is a balance principal and interest payments. And we can create a legend. What is the first one? The first one is balance. The second one is cumulative principal. And the last one is going to be cumulative interest. Okay. So let's take a look to what happens in a minute. Copy, and then we can run this one here. So I'm doing a simple plot of my balance. I want to do in the same graph. That's why it's hold on. I'm plotting the cumulative principal, cumulative interests. And this one here simply means use dots, use the dashes, a black color. Use 2 points, use points, red color. Oh, right done. And then simply using, oh, well, we need to do X labels. What do we call it? Payment month. Yeah, month. And my Y label is going to be, it's going to be in dollars. So we can semicolon these ones here. Are you with me, guys? 2 minutes to copy, and then we run, and then we improve our program, okay? Are you able to create this one here, guys? So let's run. Where is my, no. No, what is my balance here? Okay, so where is my principal? Yeah, no, this is correct. So basically, guys, what it means is the following. You don't see this very well, but the thing is that these are my interests, where are my cumulative interests. Okay, they grow. My principal, this goes in opposite direction to this one here. So as soon as you increase the principal, you decrease your debt up to a point in which my principal is exactly the same as my debt, and then they disappear. And so all this part here, guys, is what you have paid to the bank. Well, the interest, and remember, this is only a 12-month exercise, but we're going to see if we do, for example, we buy an apartment with a higher amount of money for a longer period of time, you're going to see a better picture. But for now, this is okay. You were able to create this table here, guys, this graph here. You were able to create your table.
Yes.
Okay, perfect. Let's do something more. Let me delete this one here. How do I delete? Imagine I have 10 programs. Sorry, I need to stop. I have 10 graphs. How do I delete them? Do you remember? One way, of course, is simply click on the X, but then it's close all. Remember, close all closes all my graphs. Yeah, good. Okay, so now one thing. Do you see my program? This is my first program. Do you see that I have to open my program and then enter this data here? This is data, correct? So let's create here calculations, calcs. This is the data. Do you see that, guys? And I don't want to go to my program, open my program, and input this data. I want to input to run my program from my worksheet here, my command window, but I need to put the input. I need to give the input from here. Got it? So how do we do that? I will call this amortization B1, okay? So let's copy this as a different file, amortization B1. And what I will do, guys, is I will enter inputs. So the functions works with inputs. So my first input is going to be PB. My second input is going to be annual. And my third input is going to be periods. These are names. And then what I can do is I comment this part here. If you want to comment a block, guys, block them. And where is my, well, I think I can do this in this way. Block them, and then you put comment. So now the program is going to be run, it's going to be called by other person. You are going to call this from a different program, etc. Or you're going to call this from a command window. Okay, so the input is going to be outside your program now. So your program is cleaner. What I will do is I will copy this data, I will put this data in here. Oh, yeah. I will put my PB here. I will put my annual input in here. And I will put this one here in here. Okay. Oh. The annual interest rate equals 0.05. Okay, guys. So this part here, what comes in parentheses are inputs that MATLAB is going to read. So I will provide MATLAB. I will use the command window now to interact with my program. I will provide PB. I will enter my annual interest rate and the periods. How do I run this program now? The way you run this program, guys, is you simply copy this part here. It is more or less like this one. Do you remember? You have the amortize, and then you have the data, and you call it from a different program. So that's exactly what we're going to be doing. So I will call this one here. I will call, the program is going to be called my amortization B1. This is the name of my program. I will input PB, that is 10,000, annual interest rate, that is 0.05, and the periods that represent 12. And then I simply run. Of course, now I need to disconnect this one here. I need to comment this out so my program can run smoothly. And then you have it. You have everything. You have the graph, etc. But there is a problem here. Once the program runs, I don't have my table. The table disappeared. My graph is done, but not my table. I want to have my table. Correct? So this is what is called an output of a program. So the output of a program appears in the following way. The output goes in brackets, and what is the output that we want to send to another one that is calling this program? Is called schedule table. Now, when I run this program from I will save this. Yeah, when I run this from here, I will call it whatever I want. Tab. So the name here, guys, can be whatever you can imagine. I just call it tab. Or if you want X or Y or whatever you want. Take a look to what happens. Creates my graph, creates my table. Make sense to you?
Yes.
Okay, guys, so it can create as many things as you want now. Really, you have a very small, very powerful program. We're going to be doing later, we're going to do prepayments, we're going to do a bunch of other things that are going to be extremely helpful for you, and you're going to use MATLAB to program all this stuff. But it makes sense to you? Do you understand?
Yes.
Okay, so now what I want you to do is the following. This is a more realistic case. You get a loan for $250,000. The annual interest rate is 4%. You're going to pay this for what? 30 years? Compute your table, your payment table, and create the graph. So let's say 3 minutes to do that. Okay, so this is the new data. And I want you to build all this table here. 3 minutes. And I want you guys to show me only the first 12 or only the first 6 rows of your table. I don't want you to show me the 360. Oh, yeah, wait a minute, guys. There is something more we can do here. Because I have here there is missing the 1, 2, 3, 4, 5, 6, 7, 12. Do you agree? That's important. Just to know which month we are. This part here. How do you add this part here in your Excel? Not in your Excel, sorry, your MATLAB code. How can I add 1 to 12? What do I use? Someone. Someone? Guys, how do I, this is a sequence, right? How do I create a sequence? Guys, you need to study, otherwise we're gonna get lost. We're just starting. So I need you to study the commands, review the exercises, etc. How do I create a sequence, guys? Can I create, okay, let's call x equals 1 to 12. Works or not?
Yeah.
Yeah. So what I can do here directly is I simply say 1 to 12 transposed. Because remember, it gives me a single row. So sorry, but I don't want 12. I want this to be very flexible. What I can do is I can use the same this part here.
Sorry, Professor. We're looking at Excel.
Oh my. Okay, so let me stop sharing. Now, you see MATLAB?
Yeah.
Okay, so what I have added, guys, is this part here. If I do 1 to 12, this is what I'm doing here, 1 to 12. Remember, principal, 2, it has 12 columns, so it's 1 to 12, increasing by 1. When there is nothing in between, it's increasing by 1 by default. And then it should do it, right? So now I will have next to my schedule table, I will have the 1 to 12 months. So let's run this again. So I will run this with this part here. Okay, I need this. Take a look. First month, second, third, fourth, 12, and then the table that is exactly the same as this one. Later, we'll show you how to create the titles, how to export this into Excel, etc. But makes sense to you? I'm showing Excel now. Do you see Excel?
Yeah.
Okay, perfect. Do you agree then with my MATLAB code modification?
Yes.
Perfect. Okay, so now take 3 minutes to do this. This is the new data. Of course, you're going to create a big table like that, but I want you to just show me the first, let's say, the first 6 months. Okay, 2 minutes to do that. Okay, 1 minute. You have the answers here. So you can, once you check your model, you should obtain exactly the same. Just verify the first 6 ones, the first 6 months, and then you can see if it works. Okay? Someone? Have you been able to replicate this part here, guys?
I couldn't get the payment the same.
It's 118325. It's 254%. Okay, so let's try to do this. Let me resume. Let me share MATLAB and let me know if you see my MATLAB. Do you see my MATLAB?
Yeah.
Okay, perfect. So what I can do, guys, is obviously I can change this data set. My PV now is 250. My annual interest rate is 4%. And my periods are 360, correct? This is my new data set, correct?
Yeah.
Okay, and then what I need to do is I need to call my program. My program is going to be this one here. I already have it here. I call it tab. It's going to be my amortization is going to input 250,000, 4%, and 360. And I don't want to print everything, so I put the semicolon, correct?
Yeah.
Okay, so I run this one here. This is wrong. So there is something that is wrong. So let me check. You know, if we see that there's something wrong, because take a look to this graph. Well, actually, perhaps it's not wrong. Let me check. Okay, so let me check. Let's check the table. Let's do tab. I want to see just the first 6 columns, 1 to 6. Sorry, rows, all columns. 250. No, this is too small. Do you agree? 680. Let's take a look. And this number is not good, 708. So we have made a mistake in our program, guys. So let's take a look. How do we check that? So let's go in here. Okay. I just want to my monthly. F doesn't matter because we don't use it. So the way you're gonna test, you run again your program, tab, and it will stop here. So my monthly interest rate, my annual is 0.04. 1 divided by, no, sorry. This is always 1 divided by 12. Okay, so that's the issue. So the annual rate, so it's not by periods, so it's always by 12. Well, let's put this for now by 12. Later we can move it. Make sense? So I have an annual rate is 12. So we can do if conditions there, but it's going to be always by 12.
Yeah.
Okay, so now it should do it. So let's run directly. Let's do this again. Let's see my graph. Oh yeah, but I need to delete this again. 1 second. Let me run this again. Oh, I cannot run this way. I need to run this way. Oh, now we have it. Now it's beautiful. Okay. So let's take a look to my table. I just want 1 to 6. Take a look to these values. The interest is higher, much higher, almost 3 times what you have in your principal, guys. So that's why when you buy a house, try to repay as much as you can of your principal, guys. Otherwise, they kill you. Do you see? The interests are very, very high. 1183.25, is this correct?
Yeah.
Correct. 364.82, 811, it works perfectly. So you have your own MATLAB code to do these type of things now. Make sense?
Yes.
Okay. Now, what is beautiful about this graph? Let's try to understand this graph here. What happens, guys, when you make this type of loans, the interest rates are, well, not always, are a significant part of the life of the loan, are higher than the principal. You see that? And of course, the balance decreases according to the increase of my principal. So if you can simply start paying a little more of your principal, perhaps, I don't know, if it's 1,800, just pay $100 more per month. This black curve is going to jump to the left, and the right is going to jump to the right. So you're going to be paying much, much, much less interest rates than before, than paying just your normal payment. Make sense? So this one here, guys, is extremely useful for you. It's really all my students tell me that this is the model that they use the most. Real life, in their own personal lives. You're always going to buy in at some point of time a car, a house, an apartment, or whatever. So these type of things are extremely useful. Once we have more information, more technique, more MATLAB commands, we're going to do prepayments. We're going to do a lot of things. Okay, make sense to you?
Yeah.
Okay, questions, guys. So now we continue with MATLAB learning. No questions? No questions, guys? Okay.
No.
Perfect. So we have saved this one here, so I can minimize this one here. We're going to continue now working with clear workspace. Yes, I don't need my workspace now. I don't need this one here. Oh, why is it taking too long? Clear my comments. Okay, so now, guys, what we're going to be doing, let me go back here. So let me save this one here. What is this? So let's do something that's called relational operators. Okay, so basically we have this one, we have this one, we have this one, we have this one. We have in relational operators, guys, if you want to say equal, it's double equals. And not equal is this one here. Okay, so for example, can you please create matrix A that is going to be 1, 2, up to 9, and I want B to be, let's say, 9 minus A. Okay, create these two matrices, guys. Let's create A. Yeah, let's create A equals 1 to 12. Sorry, 1 to 9. And I want B equals 9 minus A. Okay, so let's take a look to A. Let's take a look to B. Okay. So how the relational operators work, guys? They are extremely important. So imagine that I want to call it t equals a that are larger than 4. So what I'm saying is select from A. No, don't select. Tell me which elements of A are larger than 4. And what MATLAB is going to return is if it doesn't satisfy the condition, simply return 0. If it satisfies the condition, returns ones. Oh. You see, the first 4 numbers are smaller than 4, and the last 5 numbers are larger than 4. You can take a look to A. Small, so 0, 0, 0, 0, 1, 1, 1, 1, 1. Make sense to you? Let's see if there are values that are equal. So I want to see the values of A that are equal to B. So remember, logical or relational operators is we need to use equals. We don't have anything that is equal between A and B. Do you understand the logic, guys? So when you use this type of operators, what it does is simply, if the condition is not satisfied, it gives you zeros. And if the condition is satisfied, it gives you ones. That's it, straightforward. Let's create a couple of examples, okay? So let's do ID. Let's create, let's say 7 individuals. So let's create 1 to 7. Let's create, guys, for example, age. Let's create age. I will just randomly, sorry, 21, 18, 25, 19, 22, 23, 17, for example. Oh, no. So let me write this again. So let's create 21. Okay, so this is age. And let's create another one that can be called gender. Okay, so let's do this perhaps 1, 1, 2, 1, 2, 1, 2. So let's say 1 is male, 2 female, something like that. So I have created three, these are row vectors, right? I want them to become column vectors. So what I will do is, and I will call this matrix, perhaps I have ID, this is a name, age, gender. And this is going to be a matrix that is going to be composed of 3 matrices that we have created. It's going to be ID transposed, next to it age transposed, and gender transposed. So let's take a look to if this works. Yes. Two, three. You tell me when you have copied these ones here, guys.
I'm good.
Yep. 1 minute for everyone.
I'm good too.
Yep. Perfect. So now let's start using relational operators, guys. One question, okay? I want to know, this is, imagine, what we can do in this small table, we can do in a very, very big table. Okay? What I want to know is the ID of individuals that are able to drink. So remember that the people in USA, at least the people that can drink alcoholic beverages, 21 years or older, right? So let's call it OK drink. Okay, this is a name variable. What data will use? I will use this one here. But what I will select from these ones here? Okay, I want all the columns. Sorry, I want all the rows that satisfy certain condition. Do you agree?
Yeah.
What is my condition, guys? My condition is located in which column of the same variable, of the same matrix?
Second.
Is the second. All rows, second column, this to be larger or equal than 21. Do you agree?
Yeah.
This is going to give me the rows. Sorry. What columns do I want to show from here? So this is going to give me the columns, right? Sorry, the rows. It will check all the rows of this matrix. Column 2 will check for the ones that have more than 21. So it's going to put 1, 1, 1, 1. And then I want to return the first column. Now, this first example is a crucial one. Do you understand what I'm doing? So what I'm telling to MATLAB is use this matrix and select select the rows that satisfy this condition. And just return the first column. That is the ID of the individuals. Do you agree?
Yeah.
So you know what? Let's call it OK to drink, let's call it ID, because that's all what I want. So we click it. So individuals number 1, 3, 5, and 6, 1, 3, 5, and 6 are individuals that are OK to drink. Now you do the following. OK to drink. OK, drink. But I want not only the ID, but I also want the gender. Okay, should be the same, right? The only thing is that I need to report 2 columns. Which 2 columns I need to report, guys? Column 1 and 3, correct? So remember, this is matrix notation, so 1 and 3. Works like that or not?
Yeah.
Good. So I have all the individuals, the ID of the individuals that I can drink and the gender. Now I want, guys, the OK to drink, the IDs of only female. So I want to tell me the IDs of the people that is able to drink and that they are a female. So number 2. So this is OK, drink ID female. 1 minute, guys. Okay, so you tell me, where do I get the data, first of all? From the original matrix, ID, age, gender? You can do this directly, but at this point, we need some more information. But I can use this one here, right? Guys, yes or no? Because what I need is the ID of the females that can drink. Oh, yeah, that's it. The females that can drink. I have this matrix that is providing me the people that is able to drink with the gender. So I can use this matrix here. What rows I will select? The ones that satisfy this condition. And and only the first column. So what is the condition here, guys? My condition is check OK drink ID gen, all rows. What column?
Second.
The second, and I want this to be equal to 2,
2.
right? And that's it. So what I will do is, okay, it will take, the data is going to come from this matrix. The rows of this matrix are going to come for this condition. The condition belongs to the second row, sorry, to the second column. And according to my example, I want the females that are equal to number 2 in my data set, and then just return the IDs. So the third and the fifth person of my, if we go, third and the fifth, third, 25 years old, female, and fifth, 22 years old and female. Make sense? Okay, so
Can
yes.
we do the two conditions together?
Oh yeah, we're gonna do. Allow me to continue with this stuff. We're gonna do 2 or 3 more conditions later, but let's first focus on this one here, without any multiple steps to do something that later we're gonna do in a single step. Now, I want you to tell me, guys. So I want you to tell me the following. I want a vector that has the ID, the age, and the gender. Okay, I have a matrix of that. Males, not okay to drink. Okay, 2 minutes. Okay, done. Okay, so let's do this. Let's go back to our main file, right? This one here. So this is the original data, guys. First of all, I want to identify. So it's going to be ID, age, gen. This is a name, okay? Okay to, no okay to drink, right? It's a very long name for me. That's okay. So I will use this data. And then from this data, which rows I will select? The ones that satisfy the following conditions. So all rows, where is the okay to drink or not okay to drink is age, number 2, right? And I want this strictly is more than 21 and provide all the columns. I will use this data. I will select the rows that satisfy this condition, and I will return all the columns. Agree with me? Guys, agree with me?
Yes.
Okay, so if it works, beautiful. So we have 3 males. No, well, we have 3 people. 2 of them males and 1 female that are below 21 years old or younger than 21 years old. Okay, then easy. The remaining part, okay, I will add my name. My name is going to be a little longer. ID general, okay, to drink, male. Is going to do what? It's going to be the data is going to come from this matrix. Which rows? Which one is the one that now I need to look for? Gender. Which column is that? Guys? Which column is gender?
3.
3. And I want this condition to be equal to what? Males is 1. And what I need to return? All the columns. Correct, guys? So use this matrix. The rows are going to be defined by this condition and give me all the columns. Oh, sorry. So I'm doing, the names are too big. This one equals to this one. Here we go. So individuals ID number 2 and 4 are males, and their ages are 18 and 19, effectively being underage to drink. Make sense to you guys? Now, this works with 7 rows. It can work with millions of rows. This is something that we always use, guys, when we work with data. I want to select only the females. I want to select only, for example, Latinos. I want to select only the children that are between 10 and 15. You know, these type of things are extremely useful, and you need to manage them very well, please. Okay. So now imagine, guys, that you have 2 tables. You have the original table, this one. And you have another table that is linked by the IDs. Okay, so the IDs are going to be the same, but imagine we have income. Let's define a couple of other variables, income. Okay, so let's do this. Okay, I will do this directly. And let's do savings. Can you create a matrix ID, income, savings? Basically, the ID is the same. I think I call it ID, sorry. ID, yeah. ID, income, and savings. Can you create this matrix, please? Ready? Okay. So if I create this matrix, remember the individuals here, individual 1, 2, 3, 4, 5, are also linked to the previous ID age gender. Okay, so you have two tables that have different information. One has a ID that is a common to both tables. You have age, you have gender in one of them, and you have income and savings on the other one. Can you please give me a table? Let's call it income male. Just create a matrix that is called income male that has the incomes of the males. Let's do this together, and then you do the other ones. Okay, income male. Where are the incomes? The incomes are in this matrix here. Do you agree? So from this matrix, which rows I will select? Well, I don't have gender here. Where are the genders? The genders are here. And then from here, I need to select all rows. Genders are in column number 3. And I want this to be equal to 1. And I just want to give me column number 2. Do you agree with me, guys?
Yes.
Okay. Can you do the same for females? And then once you have that, I want to tell me what is the average income for a male, what is the average income for a female in a matrix. So compute income for females, and then I want you to compute what is the average income for a male and what is the average income for a female. These two together is in a matrix, in a table. Okay, females should be simple, right? So females, I just changing the name. Instead of 1, it's gonna be 2, and that's it. Now, guys, I want to let's say average income. My metric is gonna be called average income, and I want this to be in a single metric. So what do I do, guys? What is the MATLAB command for average or mean? Mean. Oops. The mean of what?
I think MATLAB might be frozen.
Oh, again, give me 1 second. Now, do you see my?
Yes.
Okay, so what I've done is I call a matrix that is going to be called average income, and this will contain the mean of income male and the mean of income female. And that's it. Okay. Now, guys, I want you to find in a single line the average savings. So create everything that we have done in a single line, but at this time, guys, I want the average savings. 2 minutes to do that. So I will copy this part here. Follow me, guys, for 1 minute. Okay. and savings are column 3, correct? So this is going to be providing me with a matrix that contains the savings. Savings is number 3. The savings for males, and this column 3 represents the savings of the ID income and savings. Guys, do you agree with me? So this is basically the savings of males, correct? Guys, do you agree with me or not?
Yes.
So what I want from you is simply the average savings in a single row. So this part here gives me the savings of males. So if I want the average of this, simply the mean of all this part. So this is the first part. And the second part is going to be exactly the same, but now for females. So basically, instead of 1, this is going to be 2, and give me the number 3. Give me the third column of the income and savings is savings. Here you go. Questions? Questions, guys? Okay, now perhaps you can tell me what is the age of the individual that saves the highest. Okay, so I want from you just the age of individual with highest savings. Okay, so we want the age of individuals with the highest savings. So what data set has the data of the gender is this one here, correct? Which rows are we going to select? Well, it's based on savings. So savings data comes from this matrix, correct? So I will select savings are in column 3. What I want. Which rows I will select, guys? I want this to be the maximum of this one here. And then I want to return column 2 that contains the age. I said age? What I said? Age of individual high savings. Do you agree with me, guys, or not?
Yeah.
25. So who's the individual with highest savings? Is this part here? Is this number 3, right? 25 years old. Agree with me?
Yep.
Perfect. So now there are a couple of other things that we can also take a look very quickly, guys, and we're going to be using all the time. You know, this is my matrix. Sometimes I want to sort by some of the variables. Okay, so what I can do is I can do sort rows, and this is the MATLAB command, sort rows of this one here. For example, I want to sort based on the second column. Do you see? When you write the second column positive, it simply sorts in ascending way. So 17, etc., etc., etc. Now, I don't want to sort this in ascending, but descending way. Just do the minus. And the minus simply sorts everything based on the second column, but minus implies go from the largest to the smallest. Descending one. Questions? No questions? So now let's go into something that is called the logical operators. Okay, so what is a logical operator, guys? This one here, ampersand, is AND. This bar here, vertical bar, is OR. Of course, this one here is NOT. We also have is none. Sorry, this is not a number. Is infinite. Is empty. Okay, so these are the logical operators that we're going to be using all the time, guys. And or not is none is inf is empty. Let's take a look to how this works. So let's call back my A and my B. The ones that we created before, A and B. It's simply A is 1 to 9 and B is, I think, 9 minus 8, something like that. So we can create, for example, a matrix that is going to be called D. And what I want from D is, what I want from D is, for example, all A's larger than 4, as before. Now let's call D1. I want two conditions. I want the values from A larger than, let's say, 2, and at the same time, and all the values of A smaller than, let's say, what, 6. Okay, so remember that the logical also returns 0 and 1. But what if I say, okay, you know what? Yeah, this is interesting, but I want to see the actual numbers. Okay, I want to see the actual numbers of A that satisfy this condition. It's very straightforward. These ones here are also positions. So what I can do is, let's call this D2, and I want from A, give me everything that satisfies these conditions. So you see that the ones that satisfy these conditions are 3, 4, and 5. Now, what is interesting, guys, here, and this is crucial, guys, because when you start programming, one of the issues that you say, okay, this is cool. I know that 3, 4, and 5 corresponds to the values that are here on A, but I want to keep the structure of the matrix. So I want to have, I know, let's see A. I want to have 0, 0. I want to have 3, 4, 5, 0, 0, 0. Do you understand? So let's call this D3. And D3 is going to be equal to, I will copy this one here. Remember, this is only ones and zeros. So what we are going to do is a very smart trick. We're going to say A times this one here. Take a look to what happens. Oopsie. It's not times, it's element by element multiplication. But okay, so let me check what's going on with D3. No, okay. And then I want to multiply, what is this one here? Yes, so it should be like that. So A element by element multiplication of my condition. Oh yeah, I need to have it's a double parenthesis here. Here we go. Yeah. When I didn't use this parenthesis, guys, it was only applying this condition. Make sense? This is one way, guys, that you're going to see later when we do more complex programs. Sometimes we want to keep the structure of the data. Do you see? So this is the way of keeping the structure of data. You do is you simply use the original data and you multiply this by the condition. And remember, the condition, when it's satisfied, it simply provides you zeros or ones. So any number by 0 disappears, it's 0, and any number by 1 keeps its own value. This is the way it can work here. Okay? Make sense? Okay. So now, can we call our ID? Wow, 816 already. Can we call our matrix this one here? Okay, what I want from you guys is the following. I want you to identify the okay drink that are males in a single command using the logical operators now. Okay, 1 more minute. Okay, so how do we do this stuff? The data will come from this matrix. The columns are going to have a condition. The condition is that check all matrices. First, the second one should be larger or equal than 21. Correct, guys? This is the first condition. But I have a second condition. This is the okay to drink. I have males condition. So again, this is going to be and. So I have a second condition that it's attached to the other one. And let me copy here. And that the third row equals 1. Agree with me, guys? And I will return, well, I can return everything. All the columns. Agree with me, guys? So I have two conditions now. You can add as many conditions as you want. I want the individuals that are okay to drink, so second column, larger or equal than 21, and at the same time are male. That the third column, this is not larger or equal, it's equal to 1. And that's it. Here we go. So we have individual number 1 and individual number 6. Individual number 1, effectively, male, 21 years old. Individual number 6, male, 23 years old. Makes sense to everyone. Guys, these small things are going to complicate your life if you don't really understand them for what is coming next. Please, you need to understand this program, this logic. That is the same for this logic is exactly the same if you apply Python, R, or whatever you want. Questions? No questions? Finally, one command that is called find. Okay, what find is gives positions when conditional is satisfied. Remember, guys, that these relational operators or the logical operators always give you 0 or 1. 0 if not satisfied, 1 if satisfied the condition. The find command gives you a specific positions. Right? So it's going to tell you position 3, 4, and 5 satisfy this condition. Make sense? So let's take a look, for example, let's go back to our, where's my mouse? So let's go back here. So let's find A. This is my A. What I want now is, let's call X equals find A larger than 4. Do you see? Now it's giving you positions. Position number 5, 6, 7, 8, and 9. This condition is satisfied. These are positions, guys. They're not values. Well, in this case, they look like values because the values are created from 1 to 9. But these are the positions. What you can do, let's call this X1. Directly select the specific values from A where this condition is satisfied. Here you go. perhaps I want X2, give me the positions, give me the values of A that satisfy two conditions. Find of A larger than 2 and find of A smaller than 7. Oh, what happened? Oh, sorry, my mistake. It's correct here. Find this condition, two conditions at the same time, A larger than 2 and A larger than 7. So what are these ones here, guys? These are not numbers, okay? They are positions. Sorry, no, they are the numbers already because I'm taking the positions from A that satisfy this condition. Okay. Let's see if you get it. I want to work now with this one here, ID, income, this one here. So let's work with this one here. Okay, so now using the find command, okay, now using the find command, tell me, tell me, savings of males or male savings. So you need to join this one with your matrix. IDH. Yeah. And I want this one. Give me the savings of a matrix that contains the savings of males. One minute, guys. I will give you a couple more. Using find, okay. So male savings, I just want the ages of the females that we have in our data set. Then I want the female older than 21. I want the income of the females older than 21 years old. And I want in this one here to present ID. To present ID. Oh, no, sorry. Yeah, this is okay. Okay, let's go. So I want to find the savings of males, female ages, and female older 21, the income of females older 21 years old. So you tell me, male savings. So I need to link two matrices, right? In one I have the gender, and the other ones I have the savings. But my results are savings, so I need to use this matrix. The data is going to come from this matrix. And the rows are going to satisfy a condition based on this matrix. Okay, but I will use now the find command. Oh, sorry. The ID germ of find what I need to find, guys. Now what I'm doing. Definitely. So I'm finding in here, from here, what column? Gender is column 3. And I want here to find male is equal to 1. So my find closes here, and I want to return savings, that is column 3. You agree with me? So find in this matrix, column 3, that are equal to 1, male. This is going to give me the rows. And I simply return row number 3 that corresponds to savings. Agree? So it's 200, 300, 250, and 350. And 350 for this guy. Make sense? So now we can go the female ages. So that's an easy one. I want to select, everything is in this matrix, right? So let's do female age equals, everything comes in here. What I need to select here, guys, using the find command, I need to find from this matrix, I need to return actually the third. I want this to be females, and return only the age, so column number 2. So these are the ages of all the females in my sample. Agree with me, guys?
Yes.
Perfect. And the last one. Female older than 21, income of female, let's save this one here. Female income older 21. I need to mix two things here, right? But I need the income, so the income comes from this matrix. Correct? Then what rows I need to find using the find command? I will find in this one here. So find in this matrix, column 3, all the females. Correct, guys? Okay, 1, 2, 3. Yeah. And which column I need to return? Income is column number 2. Oh, no, sorry. I need older. Oh, here we have two conditions then, right? Because these ones here are going to select the females. But I have an additional condition. The female needs to be older than 21. So I will have an additional condition. And this is number 2, I think. Larger or equal than 21. Agree with me? Okay. Do you agree with me, guys? Questions? Guys, please, you need to study this part here, okay? You need to be very, very familiar with this stuff. So we're starting half next week. We're going to half next class. We're going to start already building up with a lot of concepts that are going to require you to manage this stuff here. Okay, for that, you're going to receive the next homework. If you try to do this by Wednesday, okay, I will not receive this for until Monday, so that the next two homeworks, today's homework and Wednesday homework, are due on Monday. But I suggest you to start working on these ones here, okay? Are very simple examples, but once we start using huge data sets or larger data sets, the techniques are exactly the same. The beauty when we work with these small data sets is we can check, is this true? But if you work with data sets that are really large, guys, it's almost impossible to verify one by one. Okay, you can do some small sampling, etc. But the thing is that you need to be very, very proficient on this type of things. Makes sense to everyone? I will send you, give me 5 minutes. I will send you this homework. No, don't do three. Three we're gonna do next class is bond pricing. You do 1, 2, and 4. 4 is simply coding, is using text. Make sense to you guys? Questions?
Yeah, so you sent an email today saying that we just need to copy the MATLAB
Oh, yeah, I what I need from you guys is, for example, okay, these are the questions in Word. Okay, give me this, give me this. So what I want from you is the following. Oh, the answer to the question number 3 is this one here. You Control C, you do. I don't know.
Yeah.
You simply, what you do is the following. Please don't copy the text. It's much easier. If you take this one here, just down, copy this one here. You see?
Okay.
Down,
And
copy the
no
answer.
results, right?
No results. Because what I do is I have a couple of PhD students that are helping me. What they do is Control C, copy, go to MATLAB, and run the MATLAB. And they see
Okay.
if indeed this is true or not.
Okay, thank you.
Okay, perfect. I need to delete this part. I don't want to.
I did include some of the results. Do you want me to send you a new version?
Yes, please. If you
Okay.
can send me the final version is much better for me. Now,
Okay.
one thing for you guys, please. There is I need to have also because it gets complicated when you start sending me material. You can do, please, the way you write the way you label your homework. Please do this. Give me 1 second. It's going to be homework 1, 2, 3 underscore your surname. For the first one, it's going to be doc, and later it's going to be .m files. But please, I need to distinguish you because some of you have sent me the file. The name of the file is homework. Okay. Then when I copy all of them, I cannot distinguish whose homework is. So if you can please do homework 1 underscore your surname dot a doc document. Okay. Homework 2, homework 3, etc. Make sense?
Yeah, question. If we already sent you our homework, should we resend it
Can you
within
please do that? Yes, because tonight I need to send this to my students that are going to help me check that.
Great. And then this homework is due on Monday.
Yes, we're going to have two homeworks, this homework and the next homework that is Wednesday, and they are due on Monday. I prefer that you can be working on them, but I prefer to give you the weekend because you have more time, you have time to think and to correct your homework and assignment, and to just focus and study a little. Make sense?
Yeah,
Yep.
thank you.
Okay, guys, so see you on Tuesday, 6 p.m.
Thank you.
Okay,
Yeah,
see
thank
you
you.
guys. Take care. Good night. Good night.
Bye.